Hello, my name is Nicola, and in this video, I will be explaining the special products of polynomials. So first off, what are special products of polynomials? These special products are algebraic products that you will come across often in mathematics, which is why it's worth learning and understanding these special products so that you will be able to solve math problems faster. Let's start with explaining the sum and difference of same terms. Prepared right here. So this special product states that when open bracket a minus b is multiplied by open bracket a plus b, close bracket, then the answer will be equal to a squared minus b squared. Okay? And so we can solve this. We can solve a minus b times a plus b to show that it will be equal to a squared minus b squared. Okay, so let's write it out. So when we multiply brackets, we would do a multiplied by a minus b minus b multiplied by a plus b. Okay, so let's write that out. So it's a multiplied by a plus b, b, minus b multiplied by a plus b. Okay? All right, so let's multiply the brackets. So a times a, that is just multiplying the term by itself, so that's a squared. And then a times b, that's obviously ab. Okay, so we finished with a multiplied by this bracket. Now let's move on to minus b times a. So that would be minus ab. And then we have minus b multiplied by b. And so minus b times b, that's negative b squared. Because you are multiplying b by itself, but you also have this negative here, which makes it negative. Okay, so our resulting formula from that is a squared plus ab minus ab minus b squared. However, plus ab and minus ab are equal to each other, and they cancel each other out because this is a plus, this is a minus. So when you cancel those out, you are left with a squared minus b squared, which is the same as what is given in the special product here. A squared minus b squared, a squared minus b squared. Okay, so that is how this special product works. If the given brackets are equal to this, so a, if it's a minus b times a plus b, or even if it's just rearranged the other way around, where it's a plus b multiplied by a minus b, the product will be a squared minus b squared. So let's apply this to an example. Okay. So let's say in this hypothetical, we have, in a hypothetical example, let's say you have x minus 7 multiplied by x plus 7. Okay. So based on the special product of sum and difference of the same terms, because in our example, our x is our a from the explanation, and our 7 is our b from the explanation. So based on this, we can confidently say that the product of x minus 7 and x plus 7 will be x squared minus 7 squared. And 7 squared is 49. So we can confidently say that that's our answer. But we're going to check it by properly multiplying out these brackets. Okay, so let's write it down like how we did in the explanation. So we got written out. It looks a bit weird, but I think you can tell that that is going to be 7. Okay, so we have it written out similar to how it was in the explanation. So we can rewrite that as x squared plus 7x minus 7x, and then minus 7 multiplied by 7, that's minus 49. And then similar with the example, we have plus 7, we have negative 7. Those two cancel each other out, which brings us to x squared minus 4, x squared minus 49, which is the same as what we got by using the special product of polynomials. So see how, because we knew this sum and difference of same terms special product, we knew that this would be equal to, that these terms written in this format would be equal to this. We were able to get the answer a lot faster than having to multiply it out again. Okay? So that is the sum and difference of same terms. So put that away. Okay. Now let's get to square of binomial. Term A, so A plus B squared, so square the brackets, and that'll be equal to A squared plus 2AB plus B squared. However, when you have A minus B squared, that's equal to A squared plus minus 2AB plus B squared. So I'm going to expand these brackets and show how each of these are equal to each of these answers, starting with A plus B squared. Well, when you square something, you multiply by itself. Therefore, A plus B squared is equal to A plus B times A plus B. And this looks a lot like the brackets that we had when doing sum and difference of same terms. And so we know how to multiply out those. Okay, so that's A times, so we're going to multiply this A by this A plus B, and then we have this plus B multiplied by this entire bracket of A plus B. So writing that out, A plus B, and then plus B, A. All right. So now we can multiply the terms. So A times A, that's equal to A squared. A times B, that's equal to AB. And then again here we have B, like that. And then here we have B times A. So that is equal, B times A is equal to AB. And the reason why, like, B times A can be written as BA, but that also has the same value as AB because you're just multiplying the same terms by each other. It would be the same as multiplying 2 times 5 by 5 times 2. Those would both equal 10, so it doesn't matter how those numbers are arranged, they are still equal to each other. So it's just a tangent to explain that. So even though it's B times A, it's still equal to AB. And then you have B times B, which is number multiplied by itself, which is B, which then leads to B squared. And so we see that A plus AB and plus AB, they're like terms. So we can rewrite this as a squared plus 2ab. And there we go. So that shows how a plus b, when multiplied out, is equal to this given special product of a squared plus 2ab plus b squared. So that is how this is equal to this, because we know that a plus b squared, that's just multiplying the bracket by itself. Okay, and we know how to multiply out the bracket, and then continue through the process, and without having to do this whole calculation, the special product helps us know that this is what the answer will be. A squared plus 2ab is equal, a squared plus 2ab plus b squared, as shown here. Okay, so let's explain it for a minus b squared. Once again, we know that a minus b squared, it's just multiplying the bracket by itself, so it's going to be a minus b times a minus b. We're going to multiply this a by this bracket of a minus b, and this b by this entire bracket of a minus b. So continuing with that, and so now let's multiply brackets. So a multiplied by a squared. Remember, this is for a minus b, a minus b squared, sorry. So a times a, that's a squared. A times negative b, that's negative a squared, because positive times negative is a negative. Minus b times a, again, that's minus ab. We got that. And then minus b times minus b is equal to plus or positive b squared, because it is a negative number multiplied by a negative number. So that results in a positive number, which is b squared. Okay, and then once again, minus ab and minus ab again. So that is equal, so it's 2 of minus ab. So it can be rewritten as a squared minus 2ab plus b. Okay, it's written kind of awkwardly, but you can see how in expanding the brackets, in this calculation, we were able to get the same result as the given special product. So without having to do this entire calculation, we can know that a minus b squared is equal to a squared minus 2ab plus b. So let's do this in an example. I'm just going to do an example for a minus b squared, because this one can be a bit tricky with the b squared, or can be a bit tricky to understand with the b squared. This one is a bit simpler, and just follow along. So let's write it out so that our given bracket is, let's say, 6 minus y squared. Okay, so based on our rule for special products of polynomials, it would be a 6 minus y squared would be equal to, so in our example, 6 is equal to a, and our minus y is equal to minus b. So we would do a squared, which would be 6 squared in our example, which is 36, minus 2 times a, or 2 times 6, times y plus y squared. And then just rewriting the 2 times 6 as simply 12, our answer will be 36 minus 12y plus y squared. And we can verify this by expanding bracket 6 minus y. So again, 6 minus y squared is just 6 minus y times 6 minus y. Okay, right? And you know how to write that out. 6 minus y. 6 minus y. Okay, so Multiplying them out, 6 times 6 is 36. Minus y times 6 is minus 6y. Okay, and then minus y times 6, that's minus 6y. And then minus y multiplied by minus y, again, they are both negative, and multiplying a negative by a negative leads to a positive. So it becomes plus y squared. Okay, so and this is minus 6y and minus 6y, so it's two of the same. So you can rewrite that as 36 minus 12y plus y squared. Or the same answer that we got. 36 minus 12y plus y squared, which is the same answer that we got by using the special product of polynomials using the rule for the square of binomials. You see how by using the special product, we were able to get the correct answer in a few seconds without having to do this whole calculation. See, so with the calculation, we can verify that this is the correct answer. Okay? And also, I know that the y is a bit further apart. I'll just move that closer, so it's a bit easier to see, easier to understand, but yeah, this is equal to this, thus the special product is correct. So that's for the square of binomial.